Good afternoon, everyone. Thanks for joining me this afternoon. My name's Damien Brady. I'm a cloud developer advocate at Microsoft. And today I'm going to talk to you about using artificial intelligence to augment your data. So improve what your applications can do using artificial intelligence. So I want to start by just letting you know that this is a recent discovery for me, AI and machine learning. And I come from a development background. I've been a software developer for close to 20 years. And I remember the first time that I saw any kind of artificial intelligence, any kind of machine learning, computer thought stuff. It was way back when I was looking at what university I wanted to go to. And so I was at an open day at a university in Queensland in Australia. And I went into a room where there was somebody doing a thesis for their fourth year computer science degree. Right? And their thesis was on, machines thinking for themselves and emergent behavior and stuff. And I didn't quite understand what was going on. But the guy there showed me this demo that he was so excited about. This is a thing that he had done that demonstrated computers thinking for themselves. And so I looked at his screen, and it was a series of dots randomly scattered around the screen. And then he pressed a button, and the dots kind of nicely moved themselves to be nicely evenly spaced from each other. And he explained to me that he hadn't told those dots where to move. He'd just given them some basic rules, and those dots had worked out the most optimized place to be based on the communication with their neighboring dots and so on. And this was emergent behavior, and this was an example of computers kind of thinking for themselves. And I remember watching this demo and thinking, wow, this is not very cool at all. Like, I was expecting, a week from Terminator, and you gave me dots moving around a screen, right? So I wasn't very enthused by it, to be honest. I thought, well, obviously it's a little bit less exciting than I thought, and I kind of didn't end up pursuing any of that. I do remember, though, the first time I saw something that was computer thinking kind of enabled, which I thought was very cool. And ironically, it was when I was at that university doing my fourth year thesis in the same degree as this guy. My thesis was boring. It was Bluetooth and stuff. But one of my colleagues was doing a thesis on deep neural networks. And he had entered a football tipping competition. And this is a thing that happens in Australia a lot, where you get together with a group of friends. Everybody at the start of a football season will put in some money into a pool, and then every week you guess which teams are going to win each game. And if you get it right, you get a point. If you get it wrong, you lose a point, or however you want to do your scoring. At the end of the season, the person with the most points gets most of that money. So it's social gambling. So this was really popular in Australia, and I was actually involved in some of these competitions. I even ran one from an Excel spreadsheet for a long time. So this guy had done his thesis on this topic using a neural network. And what he'd done is he'd got a whole lot of surrounding data about all of the different teams in this football tipping competition, previous matches, previous years, and so on. And he had trained this neural network, this machine learning algorithm, to predict who was going to win each game. And he entered this neural network in a football tipping competition. And he won it. Like, not even by a little bit, he won it by a huge amount. And because I was doing a lot of this football tipping stuff and I just finished the same degree as him, I'm like, this is great. I don't have to do any real work anymore. I can just train a neural network to predict these games and enter all of these football tipping competitions and win money and become rich and famous and things like that. So I said to him, hey, what's involved in this? How difficult is this to actually do? And he said, Damien, this is really easy. All you need to do is train up a deep neural network with plenty of layers and a whole lot of different nodes. You might need to learn a little bit of maths that you're probably not using right now. How is your multi-dimensional calculus? So I did what any good computer science student would do. I completely abandoned it, and I went and wrote Visual Basic for the government for a few years, which is literally what I actually did. But the point is that this felt really inaccessible to me. Like that, I still don't really know what much of that stuff is, right? So it was something that, as somebody who I thought I was reasonably good at programming, looking back on it, I wasn't, but I thought I knew what I was talking about. And then this comes up and it's explained to me as very easy, and it's too much for me, right? I wasn't fantastic at math. So I abandoned that, and it really was this inaccessible thing, machine learning. But if you fast forward a few years, now I work for Microsoft as a cloud advocate, and I have access to a lot of other people who are really, really knowledgeable in AI, machine learning, and things like that. So I started hitting them up and asking them the questions as well. And the short version is that using artificial intelligence is far more accessible than it used to be back then. You can make use of artificial intelligence to augment your applications, to augment the data that you have, without really knowing how all of this stuff works under the covers. And so there's a few sessions in this learning path about data, and I'm going to be focusing on this base level of coming at it from a software developer who doesn't really know any of this deep maths, all right? But still being able to make use of artificial intelligence, machine learning, and things like that to improve your applications and to add new functionality to your applications. So let's start kind of at the beginning with what artificial intelligence even is. And this is a bit of a difficult thing to define, right? Artificial intelligence is this gigantic, broad area of computers kind of doing things that we previously thought required a human to do. And so you can think of this even as far as like way back when computers first started. You know, artificial intelligence might have included things like a calculator, because previously doing that mathematical stuff required a human, but now a computer can do it for you. And that's extended to the point where now it can understand language. Now it can understand what's in an image, whereas maybe 5-10 years ago, that wasn't really a feasible thing. So this is this continually moving field of computers being able to do things that previously we thought required a human. One of the areas of artificial intelligence, and this is a big area in artificial intelligence, is the area of machine learning, which is a way of implementing artificial intelligence. It's kind of the easiest way I can think of to describe it. And then inside that, we have things like deep learning, neural networks, and stuff like that. Now, these look like very nice, crisp, round circles here. They're not at all. They're very grey. The edges are not distinct. One of my colleagues, Seth Juarez, I love his descriptions of what this is, or what these things actually mean. And one of the ones he said to me was that if it's written in Python or R, it's machine learning. If it's written in PowerPoint, it's artificial intelligence, right? So there's a bit of a grey area here, right? In general, if you're talking about artificial intelligence, you're more likely to be selling it. If you're talking about machine learning, you're more likely to be doing it, right? So what it actually means, though, what machine learning actually means is it's a way of kind of programming the unprogrammable. So if we think about the way we write software right now, we basically have an algorithm that we provide as a software developer, and we have some data that we feed into that algorithm, and it does some processing, and at the other end comes answers. So you might provide data like here is somebody's salary, and then the algorithm is it more or less than this? And the answer is, it's less, therefore we make a decision in our application, right? That is easily programmable. Machine learning kind of flips that on its head, and things like whether this image contains a picture of a bird, for example, that is not very easy to write a series of if statements to look at pixels and determine whether there's a bird in the picture. So this is stuff that's traditionally unprogrammable. So machine learning kind of flips that on its head. And one of the ways of doing it is providing a whole bunch of answers. So here are a whole lot of pictures of birds, and here are a whole lot of pictures of not birds, right? And then you let the software or the machine learning process work out what that algorithm is for you. So in other words, it looks at all of these examples and it tries to describe what you have given it. And at the other end comes this algorithm. And you can start using that algorithm to make predictions on what comes up. So the good thing about it is, well, we call it a model in machine learning terms as well. The good thing about that is you can feed that back into your applications the same way as you did with an algorithm before. It's just that now it's not an answer. Like it's not doing exactly what you knew you were writing when you wrote all those if statements. It's giving you a prediction based on previous data. And we could go off on a gigantic tangent here about ethics and AI and things like that. But in general, if you are providing data that is really good and really accurate and actually represents the real world, you're likely to get much better predictions. If you give these machine learning algorithms biased data, you are going to get a model that is biased, right? So data is king here, making sure that you are actually providing good information for training and then getting that prediction out the other end as accurately as possible. So this is kind of how machine learning in general works. This is how it was explained to me, and it makes a lot more sense to me now. Right? So, machine learning itself, these days, you can make use of it in a number of different ways. There's kind of this separation of what is easy machine learning stuff and what is hard machine learning stuff. So the easy stuff is things like just using a pre-trained model that somebody else has written for you. So that may be something like just hitting an API with an image and saying, can you tell me what's in this image? It gives you a response, and you use that response to augment your data to do that work. That's easy stuff. You don't need to know any of the training details. You don't need to know anything apart from what the endpoint requires, and then you'll get a decent response out. The medium stuff, and these are all available in Azure Cognitive Services and a few other things, which I'll show you. The medium stuff is where you can take work that other people have done, and you can build on those models to train it to your specific scenarios. And we're going to have a look at some examples of that as well. There are ways of taking some of this really complex trained models that may have taken hundreds of thousands of training hours on machines that are very powerful, and using that to customize for your own environment. So we'll have a look at that as well. And then there's the hard stuff, right, which is training a brand new model from scratch, providing the data, choosing the algorithms, tuning all the variables and all of that kind of stuff as well. And that very much is that stuff, right? So we're not going to do any of that in this session. If you are a data scientist or a machine learning expert and you want to do that sort of stuff, there is a session for you. In fact, there's two sessions for you, which are the next two in this learning path. I would highly encourage going to those if that's what you want, because the Microsoft AI platform is really deep. We have a ton of stuff that's available to you. What I'll be focusing on, though, is mainly the pre-built AI, the cognitive services, the stuff that is in the easy and the medium stuff. I'm just going to skip back so that's not blurred out for everybody. But we have the out-of-the-box stuff, the cognitive services. We have conversational AI. We have custom AI, which is the customizing the work that Microsoft has done. And then we have stuff for infrastructure and tooling and all of the kind of things that you would want to use. We have Azure Machine Learning Services, which is the focus of the next two sessions in this learning path. And they are focused around actually helping you work as a data scientist to do this stuff properly in teams, version models, help you train these models, provide the infrastructure that you need to do so, and so on. So we have a lot of stuff there, but today, in this session, we're going to focus on cognitive services. All right, what are cognitive services? That is the next question, right? Cognitive services are essentially a set of simple APIs that allow you to use machine learning without needing to know multidimensional calculus, right? These are the things that you, as a developer, if you've ever hit an API before or used an SDK before, you can start using this stuff right now, right? You don't need to have a deep understanding of AI or machine learning or how it works, although it is useful to know what's happening under the covers, but you don't need to know that. So this fits very firmly into the easy and medium parts. And in fact, it's very much easy or medium, right? The easy stuff is just hitting a URL and getting a response. The medium stuff, you still need to know what kind of data to provide, how to continually train stuff, how to fix errors and all that kind of stuff as well. But we're going to be looking at these things in these examples today. Now, Azure Cognitive Services has a ton of different services available to you in a bunch of different categories. Here's one view of it. There's stuff around vision, speech, language, knowledge, and search. There are a lot of different services, and there are more being added all the time, more capabilities being added, and changes to these consistently and constantly. New features, new things available. We're going to look at a few of these today and how you can actually use them now. Now, if you've been to any of the other Azure-based learning paths, you might have heard of an organization called Tailwind Traders, which is what we're basing all of these demos off. So Tailwind Traders, they're a global hardware supply company, which is fantastic. But the issue that we have in this session especially is that they have very few staff members. So they're global. They have hundreds of thousands of customers, but they only have a handful of staff, and those handful of staff are only based in the US. which means that it's very difficult for them to service all of their customers in an effective way, right? So one thing that they do really well, though, is they collect feedback from customers. Now, if you're in this room in the last session, I did a session on DevOps, and this is my main area of expertise, is DevOps. And in DevOps, we talk about delivering value to users. So making sure that the software that we deliver and the infrastructure that we deliver is actually providing value, not just features, but value. So how can an organization that is global, has hundreds of thousands of customers, but only a few staff, how can they determine whether they're providing value? Well, they collect feedback. And so they can look at that feedback and they can work out what they should be working on as an organization. The problem, though, is that this feedback, these two comments that people have made, are in English, which is great if you're an American. But they also get comments in German, from all over the world. And they get some in Spanish and Chinese and Japanese. And they don't have staff who can speak these languages. Right? So how do they even know what to do to provide this value? And this is kind of these are the kinds of problems that cognitive services can start to help with. Right? So let's have a quick look at what you can do here. Now this is our application, that's Azure. That's also our application, but not the one I'm going to tell you about. So this is a list of comments that we've got from customers. People at the back, can you raise your hand if you can't read that? I don't see any hands, but I'm going to zoom in anyway. So here are some comments. Best hammer I've ever bought, worth the money, website search function is terrible, and so on. And then there's some in different languages. And so how do I know what to work on as a company? Now, one of the things we did in this example is we added another feature, which adds an analyze button, and that looks at this comment text, and it just uses out-of-the-box APIs from cognitive services to give an idea of the sentiment. Is this a positive or negative comment? What language is it in? Translate it to English if it's not in English, and then pick out some keywords so maybe we can group these comments together. Now, the way this works, and I will say that all of the code is available for this, and at the end I will give you a link to GitHub where all of the code is available. You can actually spin this up for yourself and run through these demos yourself if you want to. But the code here, it's a web application running on Azure App Service. It hits an Azure function, which hits the Cognitive Services API and returns a response. So if I hit this button, I hit it twice, so it's going to take longer. It's going to hit an Azure function, and it's going to return these details from Cognitive Services. Now, all I'm doing at this point is hitting an API. I don't need to know how the machine learning stuff works under the covers or anything like that. So I can see this comment has a very high sentiment. It's a positive comment. It's in English, so we don't need a translation. And some keywords or some key phrases are best hammer and money. So already I'm augmenting the data that I have with a bit more information that I wouldn't be able to get without somebody going through and doing this work themselves. Now, in English, that's fine, but let's have a look at, I don't speak German. So I'm going to grab that one. That is, I love your website, it's gorgeous. 100% sentiment, fantastic. What's one that I know is not so good? You know what, I don't know if any of them are not good because I don't speak these languages. But Enrique, for example, made a comment, that's positive as well. There we go. Clara. Hey, it's a good company. We've done some really good work. Clara has not such a great sentiment here because she's saying this hammer is labeled as a toy. So that's not a great comment to get on your website, right? But already we're starting to learn what is going to provide value for our customers. We can sort all of these comments by sentiment. We can automatically get this information when people leave comments. We can do this work without needing to know how the machine learning stuff works under the covers. We can start augmenting our data to behave a little bit better and deliver value to our customers. So that's great. How does this actually work though? Like what code do we need to write to get this working? And this is pretty much it. Now, I'll simplify this in a second, but ultimately we hit an endpoint, or we set up an endpoint, provide a subscription key, provide some data, just as JSON objects, and then what we get back, we read it out and so on. Now this is not very nice to read on a screen like this. The code is in GitHub if you want, and this is doing straight HTTP requests as well. So this is just doing a REST API, so it doesn't matter what language you use, this is not using an SDK, it's just hitting an HTTP endpoint. Ultimately all we're doing is we're constructing some JSON, with some details, we're sending it to an endpoint with some credentials, and we're getting some JSON back. And that is all we're doing. Right? And this is generally how all of the cognitive services work. You send a request to an endpoint, you get a response back. Now, if you didn't want to use the REST endpoint, here's an example of the SDK in .NET, or in C#, sorry. And there are SDKs for many, many languages. You're not restricted to Microsoft languages. And it does more or less the same thing. Provide a subscription key, hit an endpoint, but then you can start using objects in your .NET code to be able to deal with it a little bit more nicely rather than strings of JSON. But it's the same thing. We're just hitting an endpoint, getting a response. So this is how they all work. If you want to know and want to play with these, the Cognitive Services documentation has some amazing walkthroughs. They have a ton of stuff that you can do to actually play with this. I'll show you one of the other ways you can play with the features here as well. But you can see, if I zoom in a bit, you can see that we've got analyzing an image using computer vision in C#, Java, Node, and Python, sentiment and text analytics and stuff like that. And I'll give you a hint, the demos that I'm showing you today, much of that code is copied and pasted from Microsoft Docs, right? So there's tons of stuff that you can have a look at then. But let's move on with the problem. We've looked at this, we've got some sentiment, we've translated it into English so we can see what people are asking for and so on. So let's have a look at a couple of the comments that people have made. So you lost the details on my product return and you refused to replace it. Your website search function is terrible. But this other one, which I don't speak German, hang on, let me just do this quickly. Where was it? There we go, Liesel. So let's have a look at what she actually said. Everybody in this room can probably read it, but I'm Australian, we only speak English and we do it badly. So she said, I had to return the gloves I bought, the exchange took a long time. So we've got a product return problem, an exchange problem, and this pattern keeps coming up in our comments. We can see some negative sentiments around product returns. So let's have a look at what might have caused that. So let's have a look at our returns page. And we can see, once we do some investigation in our organization, we can see the people in the warehouse don't like using computers. So what they do is they write a little note on a piece of paper and they stick it to the product return and they throw it in a pile in the corner. And so we have some comments that are not very useful. This one I like. Table was missing 3 legs and the tabletop. And I like this one as well. Returning because customer thought frame came with picture of family. He doesn't want an empty frame. What good is that? So we have these photos of the data there, but the problem is this is data that's kind of hidden from you, right? You're not going to be able to query a database and say, can you show me the return of a picture frame or something like that? So again, we've done more or less the same thing. We've basically set up an Azure function which calls Cognitive Services and asks for handwriting recognition of what's there. And it's not perfect. This one returned customer bought too many. It's not quite perfect. We've got took many, but it's enough that we can start to extract some information. The one right at the bottom, I think, because this is literally me just scribbling on a piece of paper, so my handwriting is not that good. But the result you get, there we go, returning because customer thought frame came with picture of family, he doesn't want an empty frame, what good is that? It does a pretty good job of handwriting. Right? This is previously something you might have had to have a team of data scientists to do this work for you if you wanted to automatically recognize handwriting. But now it's just an endpoint hit. Right? So we can start augmenting these pictures with text in them, with data that enables us to search through this text. So we're getting some value out of stuff that we previously weren't able to have value with, just with the out-of-the-box stuff. All right. Again, that's exactly the same as what we saw before. It's just hitting an endpoint. I won't bother showing you any code. It's very straightforward. In the GitHub repository, one of those functions, I can't remember which one is which, just hits the REST endpoint with HTTP. The other one uses the SDK. So there's examples of both. All right. Right now, all of the stuff that we're doing is hitting an endpoint in Azure. Right? If you're doing this a lot, you may not want to actually hit Azure every time, right? Especially with images. Maybe you have handwriting recognition operating over pages of documents that are being scanned constantly, and you don't necessarily want to send that data up to Azure every single time. One of the new things that they've started coming out with is these Azure Cognitive Services being available in containers, so you can run them in your own infrastructure. Right now, we can do key phrase extraction, language detection, sentiment analysis, things like that. You can sign up for a preview of the Face API, recognizing printed text, so OCR, and then language understanding, which is a service I'm not going to talk about, but it is more about understanding the intent of what somebody asks. So rather than having them have to say specific words on your call center phone number, you can get the idea of what they want to say, and that uses machine learning to determine what this person is actually asking for. But these things are available in containers now. To use them, let's just zoom in a lot. To use them, they're just Docker containers. So you can do Docker pull, and then because you don't want to see me typing, I'm just going to do this. So this is the sentiment analysis. So it's going to pull a sentiment analysis Docker container, and then I can do Docker run, and you definitely do not want to see me type that one. So this will actually spin up a Docker container locally because I have Docker running here. And it will expose the same endpoint that I would have got if I hit the Azure endpoint. Now, one of the things that I want you to notice here is that there is a, where's the thing? We're accepting the end user license agreement, and billing equals and an endpoint here. We're also providing an API key, right? When I say that this runs on your own infrastructure, you don't have to send the data up and things like that. You still have to send data about what you're doing so that we can bill you, right? Because these are actually billed per usage. It'll last for about 10, 15 minutes without an internet connection, but then there has to be some kind of connection. The advantage is, and this is the current situation, the advantage is you don't have to send images up all the time. You're just sending a little bit of metadata about what's happening. And if you have a flaky internet connection, something that's not always connected, you can still use it. It's still okay. But it's not really for completely offline environments at the moment. So let's have a look at that endpoint. I've got it on localhost 5000, and you can see there's the container up and running locally. I can go into the service API description, and this just uses Swagger, if anybody's familiar with that, to provide information about what the endpoint looks like. And there's a couple of endpoints here. There's a post endpoint to get sentiment analysis and another one for status. Let's go to post. And the good thing about Swagger is you can say try it out and just actually provide some information. So let's just kill some of this. And we'll say, here's a document. This is in English. That's fine. And I'm going to say, there we go. And so now I can just hit execute, and it'll send that JSON to the endpoint. Now, the first time this runs, in this instance, it takes a little while, but subsequent executions will be a lot faster. So this is running against my local Docker image rather than sending information up to Azure. And when that completes, it should give me a response. There we go. And the response says, there we go. The document ID that I sent, number one, is a 99.6% positive sentiment. Now, I'm just going to show you this. Let's just turn, oh, clearly I'm not actually plugged into power. That could be problematic. Let's just turn Wi-Fi off. At least that'll save my power. Oh, that's all right. All right, we've got 29% to go in this session. So let's change this. So now I have no internet connection, right? If I go to a website, oh, I still do have an internet connection. Ah, it's because I have a wired connection. I'm so glad I did that. There we go. Now I have no internet. That would have been the ultimate smoke and mirrors. Hey, disconnected Wi-Fi, everyone. Yeah, that's right. So I can I can do another request with no internet connection, and we get a response straight away. It's spun itself up. We're not connected to the internet. So in other words, we're getting this behavior, this great stuff that Azure provides without having to really hit Azure. This is the sentiment analysis. So let's just kill that one. And we'll do a slightly cooler one, which is the Face API. And let's open up localhost 5000. And we'll have a look at that one. And so this will detect faces and look at expressions and emotions and things like that. So let's just try that one out. I'm going to not recognize a specific face because I haven't trained it on any faces, but I am going to ask it to tell me what age, emotion, what else? Smile, that'll do. And I'm going to add a new file, but I need to, just before I do that, I need to actually take a photo. Can somebody yell out an emotion that I should have? This is always dangerous. Confused? I can definitely do confused. All right. So let's just do one. How's that? Good? So let's just get that temp. So this is my, let's do date modified. This is my confused look. That's pretty confused. I'll take it. All right, let's upload that file. And again, remember, I have no internet connection still. So let's grab that file. Let's execute that. And I've asked it for not just where my face is in the image, but the age, the emotion, the smile. So it's drawn a rectangle around my face. So if I overlaid that on the image, on those pixels, that's where my face would be. It says I'm not smiling. It says my age is 36, which is generous, thank you. It says I'm a little bit angry. I'm generally neutral. So it's okay, right? There's a limited number of emotions that it can describe, but again, not connected to the internet. It's using this machine learning algorithm that it's trained running on my machine without an internet connection, which is quite cool. I've done that before and it told me that I was 40 something, so sometimes there are bugs. So some of these things you can use inside containers. I'm going to add some internet back and I'm going to try and fix my power. So you can have a look at these ones, run them on your own containers. There is a document, a blog post that they wrote explaining what is involved in these containers and what your requirements are, what you have to do to use them. This is not going to work, I think. All right, let's just speed through it. Otherwise, I'm just talking. So have a look at the documentation about cognitive services in containers as well. There's a lot of stuff that you can do there and run it on your own infrastructure. So let's have a look at the next problem. Here's a couple of other ones. Your website search function is terrible. And I think I already translated that one, but let's just have a look. I think that was Clara's comment from memory. There you go. This hammer is labeled as a toy. So sure enough, let's have a look at our products. And we've already gone ahead, we've got sentiment analysis on the comments for each of these products. And we can see that the tag we've got for here is a toy, when this is a rubber mallet built specifically for gently smashing things, right? So the sentiment is low. We've sorted all of these comments by negative sentiment upwards. So towards the end, we get some quite positive sentiments. People are liking the way that that product is presented. But it's given us a place to start. And there's something wrong here that the tags are incorrect. That one's listed as toy. This one is a nail bender, so it's in there as bender. And this one cracked a nut, which is not what we want either. So we've done the same thing again. We've used cognitive services. But the problem is this is very specific to our scenario. So it's very difficult for us to say what is in this image and get a generic, useful result that we can use to improve those tags. One way that you can find out whether it's likely to be useful is just going to the Cognitive Services landing page on Microsoft Docs and having a look at these different areas. So these are the categories that I mentioned before. So let's have a look at vision, and we can see down here with computer vision, there are a number that have demo written next to them. You can click on the demo and just try this stuff in the browser. So this is an example of the image analysis. So this is what I would think we could probably use to improve those tags, right? So let's put in an image. So this is the hammer, the nail bender, and see what it gives us back. So it hasn't actually detected any objects, so it can't outline any objects, which is okay. We've got some tags here. So it is saying tool, which is fine and correct, but not terribly useful for tagging our website, which only sells tools, right? Nobody's going to search for that. We do have hammer, though. That came back, but it has a confidence of 5.6-ish%. So it says it's noticed that there's a hammer in this image, but it's incredibly unsure about that. So we probably wouldn't look at that and say, whatever comes back with a 5% probability is likely to be what's in the image. But we've got something there. So maybe we could use it. Let's just grab another image. And this one is of a wrench. So it's noticed. Look, there's something there. But it's saying it's 71% confident that those are scissors. Right? So if we just took this at face value, we might tag that object in our product catalog as scissors. It's saying wall, not terribly useful. It's actually here for the tags, it's saying it's 96% confident that there are scissors. So this is not really going to give us what we want. We can't use the out-of-the-box stuff without any context and try to get a better result for the problem we're having, which is incorrect tags on our objects. But what we can do is start using some of the more complicated services that fit very much into this medium category. So when I showed you these list of all of the different services, you might have noticed that some of these have the word custom or customized or contextual and things like that in them. These are an example of those medium level ones where you can't just use it straight away out of the box. You need to provide a bit more context and a bit more training to what your scenario looks like. So the one we're going to look at is this customized image recognition. We have a list. We obviously know what our products are, right? So we want it to be able to recognize those products. We don't care about it recognizing mountains or trains or anything like that. We want those objects. And we can do that using cognitive services, using these slightly more complicated ones. Now, I'll show you that service in 2 seconds, but the one that we're talking about is custom vision. You can get to that by going to customvision.ai. The way it works, though, and the way these customized ones work, is they use a technique called transfer learning. So if you remember, way back when we were talking about the way we train these networks, and it was very inaccessible, right? We had all of these different nodes, we had all of these different math problems at each of these points, right? This is the way that these trained networks will work, and this is the way that we've trained those services in Azure as well. So we're using this trained convolutional neural network that knows how to detect a whole bunch of stuff, and we're trying to tune that to our own scenario. So the training that Microsoft has probably done, if it needs to recognize, for example, dogs, bicycles, apples, and tennis balls, is they provide a ton of images. In this case, there's an image of a bike, and they have told it this is an image of a bike. And they've basically used whatever techniques, and again, we don't need to know these in this session, whatever techniques to basically come up with this result right at the end that says, well, look, there's a 2% chance that it's a dog based on what I've learned, 93% chance it's a bicycle, 27% chance, 21% chance, and so on. Now, all of these nodes have a different, we'll call it just a different value. And then it does some maths and goes to the next one, and some maths and goes to the next one. So each of these nodes has some value, which ultimately ends up in this probability at the end. So we trained it on bicycles, and then we trained it on wrenches and dogs and tennis balls. What transfer learning does is it strips out that final layer where we're saying, this is the probability that it's a dog and a bicycle and a tennis ball. And we look at the nodes at the very end, or the tensors at the very end. And let's, for this example, we'll just call them numbers. And we'll say there's numbers F1 through F8, right? We may have noticed that if F1 is really high, then it looks like a bicycle. And if F4 is really low, then that's more likely to be a bicycle. Dog has a really high value for F3, F6 doesn't matter, F7 is really high, something along those lines. So we have this tuning that already works. What we do then is we take these existing layers that we've already created, and we start to tune them based on the data that we want. So we'll give it a whole bunch of hammers and then have a look at the values for F1 through F8 and see what corresponds to a hammer. So we may see that for hammers, F2 is really high, F3 is really low, the other ones don't matter. And for wrenches, maybe F7 is really high, F8 is really high, and the others don't matter, and so on. So you start using this pre-trained stuff that knows how to find objects and train it on your own specific object. And it turns out this works really, really well, provided you've pre-trained this model on things that are similar to what you are looking at now. So if we think about it for faces, the Face API actually gives you a custom one as well, where you can say, here's 20 photos of me, of Damien, right? And it will already have a pre-trained neural network that knows what a face looks like. It can identify where the eyes are, the distance between them, the nose, where the mouth is, the hair color, whatever is happening inside these hidden layers, it already knows what a face looks like. So giving it more faces, we're going to get a really good result out the other end. So this is generally what we're doing when we use these customized or custom services. We are using the existing information and we're training it for our specific scenario. So this is perfect for what we want right now. We want to give it our examples of what a hammer looks like and what a wrench looks like and get it to train on those specific things. So to do that, we use custom vision. So this is customvision.ai, and you can set up free examples of this as well, and they're restricted to something really high, like 1,000 requests for free, and then the training is slightly more, and then when you start paying for it, it turns out to be a few dollars or a few euros or something like that. The pricing changes, so I can't really talk about it, but it's not very much at all. So here's one that I've created earlier, but let's walk through actually creating one. So we'll start a new project. We'll call it Ignite Amsterdam. We can give it a description. We can give it a resource group. So this is a limited trial resource group, which is actually going away, so don't do that. Choose an existing Azure resource group that you have set up. I'm going to use this LP3S3 one, which is set up for this class. And we can set this up with a project type. There's either classification or object detection. So classification is what is in this picture. Object detection is what's in the picture and where is it. We only really care about classification at the moment. We can get it to give us multiple tags per image or just a single tag per image. So if we train it on hammers and wrenches, we can say which one of them is it, or we can say maybe this image contains both. I'm actually going to choose multi-label, and we'll see why in a little bit. But in general, I want it to tell me the probability that there's a hammer and the probability that it's a wrench, in my case. And then the domain is what I was talking about. These are the pre-trained models that we're building off. So here, we could do general, which is very much just general objects and general things. I'm going to choose retail, though. And the reason I'm choosing retail is because retail is likely trained around single objects, a single main thing in an image. Right? This is not set in stone. You can change this and see how it behaves. But let's just leave it at that. So retail is what I'm going to train off. So right now, we are going to get started. So this is fun because this has completely changed since the last time I did this demo. So the first thing we want to do, though, is we want to add images, right? We want to add images of our own scenario. So let's go and choose these images, and let's just find where they are. They're going to be in dev, demos, and then I should remember where they are. LP3S3, training images, got it. And let's go to hammers. And so these are images of hammers that I've just pulled off a site called ImageNet, which is Creative Commons 0. And ironically, these were chosen as hammers by a machine learning algorithm. So it's a bit inception-y. But these are all pictures of hammers, right? They're not very good pictures of hammers either. So remember when I said that the data that you provide is going to lead to better outcomes? If it's good data and represents the real world, then you're going to get a much better predictive model. This is not good data, but it's enough for us to be able to kind of show what's going to happen here. These are all pictures of hammers. I'm going to tag it with hammer and upload those 66 files tagged with hammer. So we've given it a whole lot of examples of what a hammer looks like. I'm going to do one more. Actually, maybe it's just the zoom. Oh, there you go. I was one more zoomed in. So this is actually not different than what I saw before. It's just when you zoom too much, it's horrible. So let's add some more images. That was hammers. Let's add some wrenches, because that's all we care about, hammers and wrenches for the moment. We'll open those. We'll tag this with wrench and upload 51 examples of wrenches. So we're basically saying, I know you've already trained on retail stuff, but just strip out that last layer where you know what objects you care about, and we'll use wrenches and we'll use hammers. So right from here, we can start, there's a train button here. So if I zoom out, you can see that actually says train. So I can train this, and what it will do is it will use that predictive model and that transfer learning to train it on the data that I've provided. Now, training something like this, a predictive model from scratch, may take hundreds of thousands of compute hours on powerful GPUs and things like that. But because I'm using transfer learning, Microsoft has already done that first initial work, and I'm just kind of tacking my stuff on at the end. So this should really only take a few seconds, and we'll get a result at the end in a sec. It says that it's done, which is cool, but we'll get a result at the end, and then that'll be able to tell us whether something is a hammer or a wrench. And so that's completed. We get an idea of the precision and the recall. So these are two different numbers for determining how accurate your model is. So precision tells you that if your model, your predictive model, says that this is a hammer, what's the probability that it actually is a hammer? And recall says that if it should have said hammer, what's the probability that it does say hammer? And these are two different values. They can be important in different scenarios. So imagine if you had a predictive model that told you whether somebody's X-ray showed signs of cancer. You'd probably be much more happy with it saying, yeah, I think there might be cancer there, and being wrong, than saying, no, it's fine, it's clean, and there actually is cancer there. So these things are fairly important. So now we've trained it, we can try it. We can do a quick test. So let's grab that same image URL that we had before, that first one, that hammer, and it says, based on what we've trained, there's a 99.8% probability that there's a hammer and a very low probability that there's a wrench. So it's done a pretty good job. What was the other one? It was the wrench. So before, remember this said scissors, and it was very confident that that was a pair of scissors, right? Now, it's 99% sure that it's a wrench and 2%, 3% sure that it's a hammer. Now, where you might run into trouble is if you have something which is a little bit of both and it says there's an 80% chance that it's a wrench and then a 40% chance that it's a hammer, you probably want to take that into account when you're presenting your final result as well. But this is doing a pretty good job. It's learned what a hammer looks like, it's learned what a wrench looks like. And remember, these were not good images to start with. So it's doing a pretty good job. So back in our application, we've wired all this up. We can hit the Analyze button and it will look at that image, send it to our cognitive services, to our custom vision AI, and it will give us a new tag based on what that prediction was. So it's hitting that for the first time. There we go. So it's saying that that is a hammer, 93% probable that it's a hammer. Our wrench down here, which is listed as clasp, that is now saying it's a wrench, 99% probable that it's a wrench. So we can now start using that to give us more, better automated tags on the data that we have. This can be really, really handy for things like document recognition. If people just send in documents and say, here's an application form, if you've trained custom vision on what an application form looks like, then it can straight away say, yes, this is one, or it's probably not. What are you doing? You're uploading the wrong file. So there's a lot of stuff you can do here. One of the other things which I didn't show you just then was that this is an endpoint that you need to hit that's in Azure. And remember, that's not always ideal. Maybe you don't have a good internet connection. Maybe you don't want to be continually sending images of stuff to recognize. So there is a way to use custom vision and actually have that image downloaded for you so you can use it in your own infrastructure. If I change the domain that I'm using to one of these compact domains, that gives me the ability to download that predictive model. So if I save that and then do a retrain, because it's now a different domain that it's building on, a different transfer learning base point, it's going to train that on the compact model, which is a much smaller, not as deep, not as many layers, but not necessarily worse. That doesn't necessarily mean that it's going to give you a worse result. But what I should be able to do then is download that artifact, that compiled, custom trained model so that I can use it in my own applications. So we'll give that another couple of seconds and then that'll let me download it. And it'll let me download it in a number of different formats. So yes, it'll give me a Docker image if I want, but it'll also give me a Core ML model, which I can use for iOS, or TensorFlow, which I can use for Android. I've actually used that TensorFlow model on a Raspberry Pi before, which is quite cool. Onyx, which is the Windows one, and then Docker, which I can choose Linux or Windows as well. So I can run a Docker image with that trained model on there as well, which is very handy. One last thing is that it's really important to retrain these if they start to become stale or inaccurate. So if we start getting incorrect results, we want to be able to fix those incorrect results, right? Especially if it's a public-facing website. So our predictions, this page will give us an endpoint which allows us to look at what we've sent, what data we've sent, and improve that if we are getting incorrect results. So let's just jump into the one I already created earlier, which is what we're actually hitting, the Tailwind products, and have a look at the predictions. And we'll see those images that we just sent. Oh, that's actually sending somebody's airline ticket, which is cool. Nope. There we go. So we sent these images. We sent this hammer and this wrench here. And it's given us a good result. But if that gave us an incorrect result, we might want to say, that image that somebody sent us, that is actually, a wrench or something like that. Save it, and then we can retrain our model based on this new information that we've given it. So we can continually improve that model and give it better information. In this case, it's probably not that useful because we're using our own objects, but if you think about a public-facing website where you're asking people to upload their own images and providing predictions, this can be really handy. The other thing is everything I've shown you is through the UI here, but everything I've shown you is also available via an API. So you can write your own software to do this stuff automatically. Find images, upload them, correct them, look at the predictions, download the endpoints and things like that. So all of this is available via code as well. So these are just a few examples of what we can do. We had a look at the sentiment analysis and stuff like that, handwriting recognition and things like that, custom vision for our own vision services, but you saw there were a ton of other ones. I don't have time to go through all of them, but I would highly recommend going and having a look at the docs on the website and also Microsoft Learn, which I don't know whether you've seen, they have a booth in the hub as well. They have a ton of different walkthroughs of actually putting this stuff together in real life looking applications. I would definitely have a look at that. You can think of a ton of scenarios for this. There's things like facial recognition that we saw a little bit of, but identifying somebody based on their face, identifying people based on their voice, customizing a voice print so that you can recognize somebody's speech if they have a weird accent, like me, for example. Or if you're speaking in a really loud environment, like a factory, you can do some custom training on that voice model for recognizing somebody's, what the words they're saying based on background noise that's not in the standard model. So there's a ton of stuff that you can do. I would highly recommend having a look at it and just having a think about what you might be able to add to your application quite easily. So Microsoft Learn, fantastic place to go. I go and have a chat to the people at the booth as well. They'll be able to show you which courses there are. There are a ton of different learning modules that involve cognitive services that let you walk through those. Definitely worth your time if you want to play with some of this stuff. So that's Microsoft Learn. These slides are all available as well. These are the other two sessions, DAT 40 and DAT 50, and these are about if you're doing your own machine learning stuff in your organization, actually doing that stuff better, working with models and inventory management, model versions and training and things like that. All the session presentations are up, aka My MS Ignite the Tour, and all of the code is on GitHub at aka MS Ignite the Tour code. So if you want to take a photo, that's probably the one to take a photo of. I will be around here for a few more minutes, but then I will be at the experts area in the hub, in Hub 12, I think it is, from about 2 p.m. onwards. Happy to answer questions about cognitive services or about DevOps. But other than that, thank you very much for your time, and I hope you enjoy the rest of the day.